In this movie, I show you how to integrate details into a 3D model using displacement. We achieve this by displacing points in 3D space. You can find the displacement node in the asset browser. Search under Utility, then Surface, and finally Displacement. Be careful not to use displacement in the bump map slot, but in the displacement slot of Output. Now we link everything. It doesn't work yet because we still have to tell the object to be changed by displacement. So in my case, I right-click on my 3D object. Then we select Render Text and set a Redshift Object tag. In this tag, we navigate to Geometry. We click on Override and activate displacement in the displacement area. Here you can see the parameter maximum displacement. With this parameter, you can define the maximum displacement for each point of the 3D model. Currently, this value is set to 1. This means that each point can be moved by a maximum of 1 centimeter. As an example, I set a value of 50 centimeters. Now I go back and click on displacement. Then I navigate to the settings. Here we find the parameter scale. By default, this value is set to 1. If I now use a pure white tone in the displacement, the point that has this white texture will be displaced by 1 centimeter. Exactly this point gets this white material or this texture and then is moved. Let's keep this simple. Let's start with a simple color. On the left side I have already prepared some nodes. I now take a color ABS node to define a color. I direct this directly into the displacement. Now I click on Color ABS, I navigate to Out Color, then to Displacement and select Text Map under Inputs for Texture. This color will now affect our displacement. At the moment you can't see any change, although there is a 1 under Displacement. Nothing happens because the color is currently black. If I change the color to white, the geometry moves up. I intensify this effect a little. I'm going to reduce the size of this window for a moment so you can see it better. I go to the displacement node and set a value. Under scale, for example, I set the value to 10. For a comparison, I have another object which is 5 centimeter high. So I set scale to 5 centimeter as well. Now, if I set the color to white, this top will be raised 5 centimeter. This is because all vertices get the white color. As a test, I set displacement to 10 for the 20 centimeter high model. I choose the color white. The surface moves exactly to the center of the object. I set displacement to 20. As expected, the top moves up 20 centimeter. The height can also be regulated by the color. Everything that is black remains on the base layer. Now let's try it with another texture. We will use a tiles texture. You can find this node in the asset browser. Under texture you will find tiles. I don't use the checkerboard pattern here. Instead I use the pattern rings one under patterns. This texture makes the displacement a bit more challenging. Out color we would now like to link to the displacement. I'm going to activate the displacement node, navigate to Text Map, hold down the Control key and click on the circle, then connect Text Map with out color of tiles. All vertices that are white are pushed out by 20 centimeters. You can see that the displacement quality depends on the geometry resolution. The higher the resolution of the 3D model, the more detailed the displacement can be displayed. Now I go to my base area. I increase the resolution a little bit here. For the segments, I will set, say, 100 by 100. This way we see more subtleties. For better quality, we would need even higher resolution. I will reset the values. You could also work with a subdivision surface object. This would work without any problems. I will position the tarp underneath. We see that a subdivision surface object can also be used for displacement. Here we could increase the resolution. The parameter for renderer also works. In the viewport we use lower values. In rendering we set higher values. We see the better quality only in the final rendering. But there are more comfortable ways. The next workflow is recommended. The resolution of a 3D model can be adjusted directly via Redshift and the graphics card. For this we navigate to the Object tag, we select Geometry and activate Tessellation. This is how the 3D model is tessellated using the graphics card. There's a parameter Screen Space Adaptive. We deactivate it. This would allow us to control the resolution in relation to our camera. We will look at that later. For now I will turn it off. We notice that the model is displayed with a reduced resolution. Then there is Smooth Subdivision. This allows us to round off the geometry. I will disable that for now. Further down is the parameter for resolution control, named as Minimum Edge Length. We use this to control the length of each edge. A smaller value results in a finer subdivision of our 3D model. If I set the value to 1, we get more polygons. Below this is maximum subdivision. This does not currently affect anything, no matter which value I set here. The maximum value is 16. This only has an influence if Screen Space Adaptive is activated. Resetting it. Later we will see exactly how this works. We could also display the edges in the rendering. For this we use the wireframe node. You can find this under Texture, Wireframe. We drag this directly into our material under Base Color. So we can look at the mesh of our model. In this node you can also adjust the line width. I activate the tag of the tarp again. At minimum edge length we try different values. For example, I set the edge length to 0.5. Or I try even smaller values like 0.1. We could try even smaller values. Of course, this leads to better and better displacement quality. Back to the node view. Let's look at another example. I will turn the wireframe off again. Let's try it with a texture. For example, let's take an image of a paragraph sign. For displacement with textures, high resolution should be preferred. Higher bitrates are also ideal. The paragraph image comes with 16 bits. For high resolution images, you can slightly soften the edges to achieve smoother mesh transitions. This often gives better results. I link out color with a text map. I set the displacement a little more discreetly, maybe 3 centimeters. Of course, we could also increase the resolution. This will lead to a finer rendering result. Now let's try another setting. I will switch off the paragraph sign. The previous examples worked well because they used pure white or black. This allowed us to control exactly which parts were up and which were down. Now I'm going to try different texture. This is a brick texture. This is from the asset browser of Cinema 4D. It has a fairly low resolution of about 500 pixels. I'm linking the nodes together. White is positioned at the top and black at the bottom. On closer inspection, we notice many details that could not actually be represented by the existing geometry. This is because a bump map is enabled by default in displacement. I will tidy up a bit for a moment. The additional details come from the Enable Auto Bump Mapping option. This option automatically visualizes a bump map. I turn this option up. Now less details are visible. What remains in pure displacement. Back to the node view. Let's try another texture. I will use a texture from Megascans. Let's link this 4K texture. The quality naturally increases with better resolution and higher bitrate. Now to the displacement. Under scale I set a height of 1 centimeter. Each area that is 100% white is increased by 1 centimeter. It behaves differently for displacement maps that are not pure white or black. This texture is also from Megascans. Connecting the texture. In this texture only the brick is darker in color, more of a dark gray. This moves the corresponding geometry down, possibly down to the bottom if areas are completely black. Therefore, the entire area will probably rise from the ground. To better visualize this, I placed an additional surface without displacement at the original position and assigned a red material to it. I zoom in closer to see more clearly what's going on. The lower surface remains in the initial position without the displacement. It is clear that the upper surface has become somewhat detached. I give the displacement different values. The geometry shifts upwards by 10 centimeter. You can see that the whole surface moves up. Scale also scales the dark color values of the texture. The higher the value, the more displacement also occurs in the dark areas. It should not be surprising if the entire geometry shifts and does not achieve the desired result. However, the problem can be constrained. I would like to set the displacement to 10 centimeter because I like that. For bricks, of course, this is not ideal. It's about understanding the concept. Of course, I want the bottom of the area to stay at the bottom. Of course, I could move the surface down myself. The problem is that the whole geometry shifts, which is undesirable. That's why there is a parameter change range in the displacement node. With this, we can reassign the brightnesses of the texture. There are the parameters old range min and new range min. This stands for the black level, that is the color we want to have on the ground. Old range max stands for the white value, so black stays black. I can make the black value darker by decreasing this value. I hold down the Shift key and decrease this value. By pressing the Shift key, I can fine-tune the value. So I can control exactly where the black level should start. The entire texture is distorted at the top. The white area will also distort minimally. To counteract this, I can reduce the new range max value. This way I also scale down the upper range a bit. It takes a little trial and error to find the right value so that the plate doesn't shift too much and doesn't move too far from its original position. I hope this illustrates how to work with different color or brightness values. Let's pull this back down. Let's look at the screen space adaptive parameter next. For this I will adjust the minimum edge length parameter. I will reset the value so that the model has fewer subdivisions. Let's activate the wireframe again. This way we can better see how the parameter works. The wireframe is now displayed. I go to the Object tag and activate Screen Space Adaptive. The wireframe is now visible. I go to the Object tag and activate Screen Space Adaptive. Now the maximum subdivision parameter becomes relevant. If I decrease this value, we get a lower resolution. This means that if I zoom in closer with my camera, the resolution will automatically increase. But always only up to the value I set under maximum subdivision. A higher value here leads to a finer subdivision of the geometry. But this change depends on the camera distance. Zooming in closer to the geometry increases the resolution. Moving away for a moment, now I zoom steadily closer to the geometry. The closer I get, the higher the resolution. The maximum value for this is the one I gave here. That's actually the gist of ScreenSpace Adaptive. There's also an option to freeze the current geometry resolution. This option can be found in the render view here at this button. If I want the current resolution to be kept, I click on this button. The current state is frozen and the resolution does not change even if I move. Turning off ScreenSpace Adaptive keeps the last frozen resolution. Let's try another example. I zoom in closer or disable the option. This automatically reduces the resolution. If I move away strongly, the resolution is reduced even more. It's hard to tell from this distance. I'm getting even farther away. Then I freeze the geometry again. If I now zoom in closer, the resolution remains the same. It matches the resolution I saw when I was farther away. This basically describes the function of ScreenSpace Adaptive and maximum subdivision. Lastly, let's look at a few more parameters. These concern the resolution that are outside the camera view. This becomes especially important when areas outside the camera view are reflected in the image. Here we can set how finely these areas should be divided, but this is a very specific feature. It's only significant when areas outside the camera view are reflected in our main image. This allows us to gain significant performance. With this, I conclude the topic displacement.